So in this video, we'll be talking about the concept of inertia. In one of the previous videos for force, we talked about how inertia is not a force, but it is related to force. A force can change an object's inertia. So we start off with the statement, an object at rest stays at rest, and an object in motion stays in motion. So you've probably heard this statement before, and it's pretty much linked to inertia. The question is whether or not this matches up with what we see around us. So is this consistent with what we experience every day? So the question posed, what if you throw a ball up in the air? So if I throw a ball up in the air, does it just keep going off forever? And the answer to that's no. It comes back down. So something needs to be added to this statement to match up with what we experience around us. Because remember, the laws of physics need to explain what happens around us. So they need to be consistent with what we see. So the statement's kind of right. If I throw a ball up in the air, the ball continues on that same path for a while. But then something happens where it causes the ball to change its motion. So if we didn't have this concept of inertia, then as soon as I threw the ball wouldn't go anywhere. So this concept of inertia is kind of right. It just needs to be changed a little bit to reflect reality. And so we were asked what is wrong with the above statement when we are asked to think about what happens when a ball is thrown upwards. So the answer to that is the motion doesn't continue perpetually. It doesn't just keep going off into the distance. The ball ends up coming back down. So there must be something causing the ball to return. So then we're asked the next question of, does the object thrown in the air stay in motion at a constant velocity until it hits the ground? And so let's recall back to our previous module about kinematics, where we were dealing with balls being thrown up into the air or balls being dropped from a height. And what's happening to that ball's velocity? So if I throw the ball up into the air, what's happening to that ball's velocity? So you should remember that the ball's velocity is decreasing. It's slowing down until it reaches zero at its maximum height. And we know that if there's a change in velocity, then there must be an acceleration happening. And so does the object thrown into the air stay in motion at a constant velocity until it hits the ground? And the answer to that's no. There is an acceleration and what is that acceleration a result of? That's the acceleration due to gravity. Changing the ball's velocity. And so you might remember from the section 4.1 about forces, forces are related to acceleration. So if there is an acceleration, there must be an accompanying force with that acceleration. So now we know what's missing from this statement. We need to include something about forces in this statement to make it match up with what we see around us, make it reflect reality. And so the first law actually is that an object at rest stays at rest, and an object in motion stays in motion at a constant velocity unless acted on by an unbalanced force. So what this means is that the ball is going, if I throw a ball up into the air, it's going to maintain a constant velocity if all the forces are balanced. But what we know is as soon as the ball leaves my hand's not acting on it anymore, and the only thing acting on it is the force of gravity. So there's an unbalanced force, And that's why we don't have this perpetual motion of the ball flying off into the air. It comes back down. And so based off of that, does the ball have a constant velocity and balanced forces, or does it have a changing velocity and unbalanced forces? Well, I think we just answered that, and it's category 2. And now let's go through some of the rest of these and see if we can get a better picture of which category these scenarios fit in. So we have a ball at rest sitting on the ground. If it's at rest, its velocity is 0, and it's going to remain 0 until something changes. So we have a constant velocity, which is 0. So the forces must be balanced. So this fits into category 1. A car on cruise control at 40 miles per hour on a straight road. So there must be forces acting to keep this car going at 40 miles an hour. And that means that it's at a constant velocity, and those forces must be balanced, making that happen. So again, this is category 1. A car on cruise control at 40 miles per hour on a curved road. Well, if we're on a curved road, then we have to take into account that velocity is a vector. So velocity is a vector. So it has a magnitude and direction. So on a curved road, we may be pointed this way at one point, and then we're pointed a different direction at another point, here and here. So the direction's changing, or our velocity is changing. So if we have a change in velocity, we must have unbalanced forces as a result. So that falls into category 2. And then finally, we're asked about the Voyager 1 spacecraft in its current state. And so we're going to need to go to another page to look at that. So we're asked about these Voyager spacecraft that were launched in the 70s, and really they were there to take pictures of the different planets within our solar system. They've just happened to survive, and they've continued on. And so we're asked to go to this website to look at what their velocity is currently. And if we look, their velocity is 38,000 for Voyager 1 and 34,000 miles per hour for Voyager 2. And if you look, their distance is changing, but their velocity is not. So their velocity is constant. So that was 38,000 and 34,300. So we have 38,000 mph, 34,300 mph. So when we looked on the website, the velocities were constant, but to get a better idea of what's going on with Voyager 1 and Voyager 2, NASA did this simulation of its trajectory. And so once it reached Saturn, it just went off into the distance, and its next goal was to get out of our solar system. So that number's not changing because it's going at a constant velocity, and it's just going off into the... So coming back here, in its current state, the Voyager 1 spacecraft has a constant velocity, so it must have balanced forces, and that fits into category 1. So moving back down here to finish up, we know that when there's an absence of unbalanced forces, or when all the forces are balanced, we move at a constant velocity in a straight line. And that YouTube video that NASA put out shows that. It's moving in a straight line out of our solar system. And so when we are subject to forces of air resistance and friction, that causes the velocity of an object to change, because those forces aren't balanced by anything else. And so that affects the object's inertia. That's why it doesn't keep going. And that's what's different between on Earth here and then out in space.